Hi class, we can continue our study in chapter 4 talking about triangles and congruence. And in this section, we want to move into section 4.3, and this is called congruent triangles by SSS and SAS. Now those are just two methods to basically prove two triangles are congruent. And SSS stands for side, 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 and SAS stands for side, angle, side. All right, we'll start with the SSS first. All right, so postulate 4.3-1. Side, side, side postulate. So it just says this. If three sides of one triangle are congruent to three sides of another triangle, then the two triangles must be congruent. So if you have these two triangles here, triangle ABC and triangle DEF, we see here that this side is congruent to this side is congruent to this side, and this side is congruent to this side. When you have that case, right, where three sides are congruent, right, and they don't, what I mean is not all three sides the same length, but just that the corresponding sides are congruent of the two triangles. Then what we are able to say is triangle ABC is congruent to triangle DEF. All right, let's do an example. All right, so let's prove triangles are congruent. All right, so I've got this rectangle with a transversal between it, and I'm given that side AB here is congruent to side CD, and side AC is congruent to side BD. All I want to do is I want to prove that triangle ABC is congruent to triangle DCB. This one's pretty easy. So we'll do a two-column proof here. All right, so start with your given statements. The next thing we want to do is we want to have this side right here, because that's the third side of each triangle. Well, side CB is congruent to side CB, obviously, all right, and that's the effective property of congruence. So now what we're able to say is I have this side congruent to this side congruent to this side, and this side is congruent for both triangles. So we have a side, side, side. So we're able to conclude then that triangle ABC is congruent to triangle DCB, and that's by the SSS postulate. All right, another postulate. So the side angle side postulate, the SAS. If two sides of the included angle, so what that means is you have the angle and then the sides that form that angle basically, all right, of one triangle are congruent to the two sides and the included angle of another triangle, like this, then the two triangles are congruent. I want to stress, this is incredibly important, that you must have a side, then the angle in between, and then the other side on the triangles for them to be congruent. So here, if side AB is congruent to side DC, angle A is congruent to angle D, and side AC is congruent to side DF, we can say that this triangle ABC is congruent to this triangle DEF. All right, let's prove a triangle congruent here. So given the figure with the congruent segments are shown by equal number of tick marks, as we've seen, right? And I want to prove here that triangle ABE, so this triangle ABE here, is congruent to triangle CBD. All right, two-column proof. Start with what's given here. All right, so we start with side AB is congruent to BC here, and EB is congruent to BD. So what I want to do is I want to get that included angle, that I want to say that somehow that angle 1 is congruent to angle 2. Well, just by looking at it, we can say that angle 1 is congruent to angle 2, and that's just by the vertical angles theorem, right? Because these two are vertical angles. So now look, I have side, angle, side, angle, side. They're congruent. So it must be that triangle ABE is congruent to triangle CBD, and this is by the side, angle, side postulate. All right. So let's talk about identifying congruent triangles. And what I want to do here is I want to say, can we use SSS or SAS to prove the triangles are congruent? So if there's not enough information to prove by side angles, side, 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 or side, angle, side, then write not enough information and explain why. All right, so for this one right here, let me go back, sorry. Here I have this triangle and this triangle. Well, what I see here is I have one side congruent, two sides congruent, three sides congruent. So we can use side, angle, side to prove the triangles are congruent. We have all three pairs of corresponding sides being congruent. All right, let's look at this one. All right, so here I've got this triangle and this triangle. I see that this side is 10 millimeters here. Great, same as that. Angles are the same in between. Okay, and then I have 13 millimeters, 13 millimeters. So I had side, angle, side being congruent on both. So we can use side, angle, side to prove the triangles are congruent. We have two pairs of corresponding sides congruent, and their included angles are congruent. Awesome. All right, let's take a look at this one here. All right, so here I have side, great, side, great. So I have two sides that are congruent. But notice how this angle here is the included angle between this side and this side. We would need to have this angle here be congruent with this one to use the side angle side postulate. But we don't. It's over here. It's not included between this side and this side. So here there's not enough information. Two pairs of corresponding sides are congruent, but notice that we do not have the included angles as congruent. So we can't prove that these two are congruent. All right, in the second triangle, see that the arc is not in the included angle, like I said. All right, this one right here. Can we use side, 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 or side, angle, side here? Well, I have this right here congruent with this side. Great. This right here congruent with this side. And then they share a common side. So as you saw way back in how we started, what we used here was the reflective property, right? To say, well, this side for this triangle has to be the same as this side for this triangle. So we can use S here. Three pairs of corresponding sides because the triangles share, as I said, that common side.